Hello, welcome to Easy as Pie with Mr. Carpenter. I am Mr. Carpenter, and this is the Algebra 2 Stats Review video going over the material. So let's look at number one. Cassie wants to design an experiment to determine the effectiveness of... forgive my distraction. The effectiveness of a drug that will improve focus. And her friend points out that she should consider the fact that people may have differing levels of focus, either by genetics or by lifestyle. So what type of variability is this? Well, if you'll remember, when we think of induced variability, we think of caused variability. So in variability that I'm putting into the study. So in this case, that would be the pill that's doing focus. If you have measurement variability, that involves differences in measurement. So things like reaction time, rounding, and whatnot. And then we have natural variability, which is just the variability that happens from person to person, right? So things like genetics and the fact that people may have differing levels of focus, either by genetics or by lifestyle, right? So this is a perfect example of natural variability. Number two, the time it takes students to walk home from school is a normal distribution. So when we see a normal distribution, we are allowed to go into our calculators and calculate what's called the normal CDF. And I don't have the ability to show you a calculator on here, but I can tell you what buttons you're going to be pressing. So it will be second vars, which takes you to your distribution screen. And then you go to normal CDF. Right? And from there, you'll see a screen that allows you to type in a lower bound, which in this case, I want to know between 13 and 19 minutes. So 13 is my lower bound, and 19 will be my upper bound. Then it'll give you this mu symbol, which means the mean. That is 16. It'll give you a sigma, which is a standard deviation, and that is 3. And then you will just hit paste at the end. So we got 13, 19, 16, and 3. And that will show up in a line on your calculator to where you'll hit enter. And if you do all that, you'll get 0.68 rounded to the nearest 100. We'll say 68%. Now you'll notice 68% is not an answer choice over here because I didn't ask for a percentage. I asked if 50 students walked home from school, how many of them, or a sample, if I take 50 students who walk home, how many of those would I expect to take between 13 to 19 minutes? So essentially, I need to know what 68% of 50 is. So I can just take 50 and multiply it by 0.68. And that will give me 34 students. So that would be B. Okay. Number three, Kathy wants to study how people respond to a dropped $20 bill on the street. She notes that out of 100 people, 89 returned the bill. So this example of what? Well, it cannot be an experiment because in every type of experiment, I need some kind of control. I need some kind of control variable. And the researcher puts into groups, not the people themselves. And you'll understand what that means in a moment. Researcher puts into groups. For example, right, if I'm testing the effectiveness of a sleep pill, right, then I'm going to put 50 people in a group that don't receive the pill, track their sleep. And I'm going to 50 people to another group and track their sleep when they do take the pill, right? I put them in the groups and determine what variability they got. With an observational study, however, which is the answer here, it's different, right? I didn't tell people whether or not to return the bill or not, right? I'm putting them into a situation where they themselves put themselves into a group, right? So either they're in the I returned the $20 bill group or they're in the I did not return the $20 bill group. So in that case, I'm just observing what group they put themselves in. And of course, it's not a survey because I'm not asking a question. Then we want the short answers. We want to find out what students want as themes for the Spirit Week, and we need a random sample of students. Now, you can't just say survey everyone because I clearly want a sample, not the population. We're assuming it to be not feasible to get the population here. So we have to think about how I'm going to get a sample that minimizes bias. So where am I going to be and how am I going to do it? The answer that I gave is I'm going to be in the cafeteria. Okay, because the cafeteria is a location that every student goes to, at least semi-regularly, because everyone eats food to live. Okay, not going to be in the gym, not going to be at math club, right? And I'm going to survey how about every fifth student that walks in? Not going to survey the first 50 students, because then I'm going to get, the 50 go-getters, right? Or not the last 50 students. I want students that come in from, or maybe 7th graders get to go to lunch early for some reason. Then I get only 7th graders in my study. Okay? That's just one example. There are a bunch of different ways you could go about this. When we're minimizing bias, I want every type of student represented in my study. Every grade level, every academic performance, every type of club. So I want to think about how I can get all of those proportioned well in my sample. Number 5 is a number normal distribution. So we can get in and do a normal CDF. So a normal CDF. Okay. My lower bound is 10. My upper bound is 15. My mean is 11. And my standard deviation is 2.5. And if you, of course, when you type it in and then you hit the paste button, this is how it will show up. And then you'll hit enter on your calculator. So 10, 15, 11, and 2.5. And then you hit that and you get 0.60, essentially 0.60, which as a percentage would be 60%. And in this case, they do want a percentage. So that is my final answer. 60% of the spaghetti will cook between 10 and 15 minutes. And that takes us into number 6 and 7, which are going to deal specifically with our confidence intervals and our ability to make inferences. So the proportion of adult males taller than 6 feet is 14.5%, or 0.145. We got a group of bikers. Their proportion of people taller than 6 feet is 23.5%. And they want to know if that is statistically significant, right? Is that unusual for them? So they run the simulation where they take 1,000 samples of 50 random men using this population proportion, and they find out what their mean was, and they make this histogram that you see here with this mean and this standard deviation. So to find the 95% confidence interval, you got to remember that 95% of the data is between 2 standard deviations. So I'm going to take my mean and I'm going to add 2 standard deviations, and I'm going to take my mean and I'm going to subtract 2 standard deviations, and that's going to give me that interval that I really want. So let's do 0.143 plus 0.049, which will be 0.192. Oh, wait, no, sorry. 2 standard deviations. We need 2 of them. 2 times 0.049 equals 0.241. And then 0.143, I'm going to subtract 2 standard deviations. 0.045. And now when I'm making an interval, the easiest way is to treat it like a coordinate, where the lower bound is 0.045 and the upper bound is 0.241, right? And 95% of the data lies in between those two numbers. So is their proportion statistically significant? Well, since their proportion falls inside this 95% confidence interval, there's a good chance it's just a coincidence. So because of this, no, it's not statistically significant. It is within the 95% confidence interval. Last one. Average American sleeps 7 hours a night with a standard deviation of an hour, and we put in an experimental pill and we introduce it to 60 subjects, and they average 7.4 hours of sleep per night. So what is the induced and natural variability? Well, induced is caused. So what's causing it? Well, I'm throwing in an experimental pill. But how could sleep vary naturally, right? Different sleep habits, genetics, even diet, right? How much caffeine do you have before bed can impact your sleep a lot. So we need to know, right? Did the pill actually cause this, or was it just a sample of humans that just sleep more? So we ran a simulation again. Took 1,000 samples of 60 Americans using those numbers and identified their sample means. So the mean of the means is 7, and the standard deviation is 0.13. And we can use this again to make a 95% confidence interval. So 7 plus 2 standard deviations. 7.26, and 7 minus 2 standard deviations, which is 6.74. And once again, I find the coordinate method. It's not actually a coordinate, right? It's a lower bound of 6.74 that goes to an upper bound of 7.26. And I'm using these because I'm not including those numbers in my intervals. If I was, I'd use brackets, but that's not important right now. So once again, 95% of the data is in with those two numbers. But 7.4 hours is outside the interval. It's greater than 7.26. That means there's a less than 5% chance that the group just happened to have a state of mean average sleep of this time. So I would say it's likely the pill works because their mean is outside the confidence interval, which gives me a good inference that likely the induced variability is working in this experiment. And that's all for this review. Thank you very much for watching.